Welcome to the deep dive. You've brought us an incredible stack of sources today, and, well, they really paint a picture of technology and science moving at a dizzying pace.
They really do.
We are going to shortcut your journey to being well-informed on two critical and frankly conflicting trends that are defining the immediate future.
Right.
First, the escalating race for perfect visual realism in AI, and then, at the same time, this growing crisis of trust among the very developers building these systems.
It's a fantastic contrast, isn't it? We have this almost limitless capability being presented by generative AI right next to a fundamental reliability problem that threatens to undermine the whole thing.
Exactly.
And beyond AI, our sources contain some truly mind-bending scientific breakthroughs. I mean, from bending geological time in a lab to designing decentralized infrastructure that could reshape global water access.
So our journey today is all about extracting the most critical nuggets for you. We'll start with the latest leap in visual capability, the Qwen Image 2512 model. Then we pivot to the reality check provided by the 2025 Stack Overflow Developer Survey. After that, we take a deep detour into some monumental science innovations and wrap up with a quick roundup of the most trending AI tools and their use cases.
Sounds good. Let's jump in.
Let's do it.
Okay, so let's start where the immediate headlines are, which is the pursuit of perfect digital mimicry. The foundational model we really need to talk about is Qwen Image 2512.
Right.
It's an update to its predecessor, Qwen Image, but the sources suggest this isn't just an incremental step. It feels like a substantial jump toward, well, unblemished realism.
And when we talk about unblemished realism, we really have to zero in on human subjects.
That's always been the challenge.
It has. For you, the listener, the key benefit is that this new model substantially reduces that telltale AI-generated look.
That uncanny valley effect.
The uncanny valley, precisely. Historically, generative images of people often had strange artifacts, misaligned eyes, blurry hands.
All those little giveaways.
And this seems like an all-out effort to just eliminate those flaws.
And this capability is crucial because the stakes for visual fidelity are just rising exponentially. The sources really emphasize the aesthetic improvements beyond just rendering people.
Okay.
We're now looking at much finer, more natural detail and complex elements. So think about the specific texture of animal fur or the subtle variations in a vast mountain landscape.
So if you're using this for professional content creation, that granularity is where the real value is.
That's it. It's no longer about getting a rough shape. It's about getting photorealistic detail that actually holds up under scrutiny.
I found the technical differentiator fascinating, particularly when it comes to text.
Oh, yeah.
We all know that text-to-image models have famously struggled with accuracy when you ask them to render text within an image. They often produce, garbled, nonsensical letters.
Precisely. This updated model tackles that head-on. It shows greatly improved accuracy and layout for rendered text, which is, absolutely vital for advertising, packaging design, or any media where you need signs or captions.
And it has better multimodal integration, too.
It does. It means it can better understand context from surrounding text or even other images, which leads to more coherent and, purposeful outputs.
And its performance isn't just theoretical, right? This has been tested.
Rigorously.
Yeah.
The model was introduced in December 2025. It's available at Qwen Chat, and the reports mention it demonstrated superior performance in over 10,000 rounds of blind model evaluations against major competitors.
10,000 rounds. That's a powerful validation for anyone looking for the current state-of-the-art in open-source T2I models.
The market significance here is undeniable. As realism accelerates this quickly, the barrier to entry for high-quality content creation just drops dramatically.
We're moving into a landscape where the cost and time of traditional photography, or CGI, is being challenged daily.
Absolutely. Business leaders aren't just tracking these foundational models for fun. They're tracking them because they directly impact marketing budgets, educational material, even creative staffing decisions. This tech moves beyond being a novelty and becomes a direct market disruptor very, very quickly.
That sets the stage beautifully for our next topic. Because if the capability is soaring, where does the reliability stand? We're going to pivot now from the cutting edge of creative tech to the raw reality of the people building it, based on the 2025 Stack Overflow Developer Survey.
And what's so striking here is the massive contradiction.
It's a huge one.
This is the core conflict facing the entire software industry right now. It's why this survey is so vital. We have immense adoption, but it's coupled with this profound distrust.
What is the numbers?
The metrics are stark. 80% of developers are now using some form of AI tool in their workflows. It's a huge percentage.
50%.
Yet only 29% of those developers actually trust the output they receive.
Wow. 80% use it, less than 30% trust it. That trust deficit, as you called it, it must stem from some concrete frustration.
It does. The developers report that these tools are consistently almost right, but not quite.
Ah, the worst kind of wrong.
It is. It creates the scenario where you have to spend more time debugging the AI solution than you would have spent just writing the code yourself in the first place.
And the sources back that up with a really alarming statistic.
Yes, 66% of developers report spending more time fixing AI-generated code than it saved them.
Think about the economic implications of that. For a large organization, adopting an AI tool that requires human oversight to fix its work 2/3 of the time, that's not an efficiency gain.
It's an overhead cost, a massive drag on productivity.
So if the tools save you 0 time, or even cost you time, why are 80% of developers still using them? Is it just curiosity, or is it pressure from management to integrate AI, regardless of its functional correctness?
It's likely a mix. They have to know how the tools work, they have to integrate them because their peers are, and maybe they're still hoping for that one magic time the AI gets it 100% right.
But the strategic takeaway is clear.
Crystal clear. The industry has to pivot. The focus needs to shift from simple integration to verified reliability. Developers aren't asking for magic, they're demanding tools that are functionally dependable. It just reinforces the sustained need for trusted, human-verified knowledge in the tech ecosystem.
The race for realism in images must be matched by a race for reliability in code.
That's the perfect summary.
That tension, the dizzying speed of capability versus the slow crawl of reliability, is the defining theme of the moment. Now, let's widen the lens significantly. We need to shift gears and look at 4 truly monumental scientific breakthroughs covered in the source material. These feel like foundational changes that will impact infrastructure and biology for decades. We're going to slow the pace down here and spend some measured time absorbing these ideas.
Let's start with a facility that sounds like it belongs in a science fiction novel. China's time-bending centrifuge, Chief 1900.
The claim is just so ambitious that it can compress centuries of geological processes into just a few days of simulation time.
It is genuinely hard to wrap your head around. We're used to modeling weather or market trends, but accelerating geological time, that seems like a complete paradigm shift.
How do the sources explain the mechanism for compressing centuries? What specifically can they simulate with this?
The mechanism relies on simulating immense forces that typically act over vast stretches of time. They use extreme pressure and temperature modeling. Think of it as a kind of hyper-accelerated weathering and erosion.
I see.
This allows researchers to fast forward through decades of environmental scenarios that are otherwise impossible to study in real time. For instance, they can simulate exactly how pollutants might migrate through soil and groundwater over 1,000 years. But they do it in a matter of days.
The predictive power for massive, long-term civil engineering projects must be immense.
Absolutely. The sources provide a very concrete illustration. They can take a 3-meter physical model of a dam and test it under the exact stress equivalent of a 300-meter real-world wall.
So engineers can predict long-term structural integrity and failure points with a degree of certainty that was previously unattainable.
Exactly. This moves beyond engineering and becomes a geopolitical advantage in large-scale infrastructure planning and, of course, environmental hazard mitigation.
Now, moving from land stability to water scarcity, another major innovation detailed in the sources is Flotion's world-first commercial subsea desalination facility. This takes the concept of water infrastructure and puts it 300 to 600 meters below the ocean's surface.
This is a brilliant example of leveraging physics for efficiency. Traditional desalination plants are incredibly complex, expensive, and, of course, energy-intensive. Flotion's innovation is using the immense natural ocean pressure that already exists hundreds of meters down to operate the system. This drastically reduces the energy needed for the reverse osmosis process.
So the deep ocean essentially provides the heavy lifting for free. What does that translate to in terms of real-world impact and energy savings?
Quantifying the impact, this system slashes energy use and emissions by 30 to 50% compared to traditional land-based plants. It's a game changer for sustainable water access.
And it's decentralized.
That's a key part of it. Each operational pod is designed to serve up to 37,500 people, offering scalable solutions in water-stressed coastal areas. Initial projects are already moving forward in high-need regions like the Mediterranean, the Red Sea, and the Indian Ocean.
Next, let's turn to biology. Specifically, the revolutionary news about the Japanese tooth regrowth drug. The sources confirm that after years of successful animal testing, this drug is now moving into human trials.
The prospect of regrowing lost teeth, moving beyond implants and dentures, feels truly astonishing.
It really does.
And this is a breakthrough in regenerative medicine. It's not gene therapy. It's a monoclonal antibody treatment. To understand the mechanism, think of it this way. Your body has a built-in stop switch for tooth growth after your baby teeth and adult teeth come in.
And that switch is controlled by a protein.
A protein called USAG1. The drug works by disrupting USAG1's function, essentially turning off that stop switch and unlocking the body's dormant ability to grow new teeth.
So by targeting the natural inhibitor, they allow the body to continue a process it was already capable of. That's a fundamentally different approach than trying to grow teeth from scratch in a lab.
Exactly. It utilizes the body's own intrinsic potential. This holds massive potential globally, not just for adults who have lost teeth, but also for people born with conditions like anodontia.
And if the human trials proceed successfully, which is always the biggest hurdle, the timeline projected by the researchers suggests the drug could potentially be available to the public around 2030.
A tight window for such a monumental medical development.
It is.
Finally, let's discuss efficiency in architecture and vehicles. Korean researchers have recently unveiled a breakthrough in transparent solar technology windows that generate power without blocking the view. This is key to making solar practical for dense urban high-rises.
The technical details in the sources explain that the system combines distributed Bragg reflectors with bifacial silicon cells. For listeners, that sounds incredibly complex, but what does that technical combination do on a functional level?
Simply put, the Bragg reflectors act as a highly selective mirror. They are engineered to redirect only the invisible infrared light, the heat, and non-visible energy spectrum to the bifacial solar cells embedded in the frame.
And at the same time?
At the same time, they allow 75.6% of the visible light to pass straight through.
That's a high degree of transparency while still harvesting significant energy.
It is. This makes see-through solar a viable technology for powering zero-energy buildings where aesthetics and natural light are prioritized. And imagine the application on electric vehicles, where every window and panoramic roof could contribute power, significantly extending range without adding weight or clutter.
It's a fundamental step toward integrated energy generation in everyday materials.
Yeah.
What a phenomenal transition of topics.
That's quite a range.
We moved from engineering the past and securing the future of global water to solving dental health and powering our cities with see-through glass. Now let's loop back to the tools that are rapidly reshaping our daily professional lives. We're going to dive into the current trending tools covered in your sources.
Let's get through this fast-moving list.
First up, we have Giselle, an open-source tool that lets users build and run complex AI workflows. Really streamlines multi-step processes for engineers and data scientists. Then there's Brief My Meeting, also open source, designed to tackle meeting overload by delivering concise AI-generated meeting briefs right to your inbox. Saves significant review time.
For content creators and marketing teams, Creaibo is trending. Its purpose is to help create faster, better content. But the key feature is its ability to accurately capture and maintain your specific brand or personal voice.
In the HR and recruitment space, Foundire is automating the initial screening process. This tool handles the entire process of first-round candidate interviews, letting human recruiters focus on top-tier prospects and final assessments.
And for those working in audio production, there is Chatterbox Turbo, a fast, expressive, open-source text-to-speech model. What makes it noteworthy is that it includes native watermarking, adding a layer of security and source attribution to synthesized audio.
Developers are also raving about Dropstone, described in the sources as the recursive swarm IDE. This is automation on a grand scale, capable of handling up to 10,000 agents simultaneously in a single browser tab.
And we mentioned it at the top, but it's actively trending. Qwen Image 2512, maintaining its status as the state-of-the-art open-source model for providing that high level of realism we discussed.
Finally, a tool focused purely on personal well-being. Oob, a specialized AI coach designed to offer personalized relief strategies focusing on sleep, stress, and anxiety.
A really diverse set of tools.
We covered immense ground today, moving from the quest for perfect image realism and the stark reality of developer trust to monumental breakthroughs in geological time compression and life-changing medicine. This rapid development curve demands not just innovation, but also accountability.
That's the key synthesis. Consider the tension we've highlighted. On one hand, we have the cheap 1900 centrifuge, allowing us to fast forward Earth's aging processes in a lab to ensure infrastructure verification over centuries.
Right.
On the other, we have a developer community reporting that 2/3 of their AI tools are actually costing them time because of errors. These new capabilities, from high-realism content generators to hyper-efficient subsea tech, they all demand new standards of fundamental verification and reliability in our software systems.
It's a great point.
So the question for you, the learner, is this. If we can accelerate geology in the lab, how do we accelerate the development of trust in our digital tools? That's the next frontier we need to solve.
A powerful thought to reflect on. Thank you for diving deep into these sources with us today. If you found this useful, please follow and share this deep dive with someone else who loves to be well informed.
Thanks for listening.
See you in the next episode.